Fact of the matter today, 2 beers, 2 Canadian guys. Now, what would the normal course of events be? The 2 Canadian guys would open the 2 beers, drink them, right? Fact of the matter is very different. And John Swain is here to prove it.
Hi Jay, how's it going?
Good.
So, a couple of cold beers. In fact, these are very, very, very cold beers. These are what the physicists call a super cooled pair of beers.
Wow.
So these are sat in the freezer for
I feel like one of the Mackenzie brothers.
Yeah, big coffee. So these have been in there for like about 3.5 hours, and they're very, very cold. They've actually gone below the temperature.
They've been in the freezer.
In the freezer. Below the temperature where you'd expect beer to actually have frozen. So this is 0 and a little bit down below. Except if you look at it, you can see this is still liquid. And the interesting thing is you can take a liquid like beer or water, you can take it below the temperature that it should freeze at, when it should rearrange itself into a solid. But if you do it very gently, they get kind of confused. They still think, oh, molecules, I'm still liquid. They need a little reminder, a little nudge, a little something, and then they'll suddenly go.
Shock them
so
into
let's try and give this guy a little whack and see what we see. Maybe you want to hang on to yours.
I'll hold on to this one. Oh, what's happening there? Oh my goodness! It's freezing before our very eyes.
That's right. There it goes. Okay, this is not going to be too good to drink, as you can imagine, because it's basically turning solid.
Tell me again what actually transpired there.
So the idea is you cool things down, and below a certain temperature, the liquid really should have turned solid.
Yeah.
But the molecules don't know they're supposed to be that way yet. They haven't had a chance to move around. So you've got to give them a little jolt and sort of give them a little hint to rearrange themselves around.
Okay.
And then all of a sudden, they'll crystallize. So there you go. That beer is now filled up with ice.
Okay. Can I try this one? I want to try this one.
Let's clean it off so that
we can show you just how this. Okay.
This is genuinely
1,
liquid.
2, 3.
You may have to give it a good hard whack.
Oh, this one's very stubborn. Okay, a little reminder. You're supposed to be frozen. There we go.
And there you go.
Some beers are more stubborn than others. That's fascinating.
And there you go. This one's an easy one to do at home. And it really does point out to something that's really, really critical. It's not just the temperature that decides whether something's going to be a liquid or a solid.
Right.
Sometimes you've got to give it a little nudge to decide to go into the state that it should be.
Of course, many people I know would be reluctant to do this at home because now they have a frozen beer. You don't want that.
You can sit that in a little bit of warm water and it'll be back to normalcy.
Now, this is a warm beer. So I'm not quite sure why somebody handed me this from off camera, but I don't think, no matter how hard you hit this one, nothing's going to happen to it. You've got to leave it in the freezer. We think, what, 3.5 hours?
3.5 hours. Depends how cold the freezer is. You have to fiddle around a little bit.
One experiment you can do at home, no propane torch in this one on Fact of the Matter.